My name is Jirna. Today I am presenting my project. The project name is Shopper Spectrum, Customer Segmentation and Product Recommendations in E-commerce. The core idea is in the e-commerce business generates huge volumes of transactional data every day, but the raw transactional logs cannot be don't tell you who is your best customer and what to recommend them. This project turns raw transactional data into two business ready outputs. The first one is customer segments. So marketing can target the right people with right message. And the second one is product recommendation. That means right product recommend to the right person who buy more. And I build this end to end from raw CSV to working Streamlit web app. Coming to the Coming to this notebook covers the full pipeline required for this admission. In this Python notebook, we covered the data collection and understanding data pre-processing, and we have done EDA and we have done RMF, feature of engineering and clustering, cluster labeling, cluster visualization, saving the model for Streamlit, and the last final one is product recommendation system. That means item-based or collaborative filtering. And coming to the problem statement, the data set is transactional level data from an online UK retailer. That is, in the data set, we have invoice number, product code, description, quantity, date, price, customer ID, and country. The real business use case this solve is targeted marketing campaigns based on customer segment. And the second one is personalized product recommendation on the platform. That one is identifying at risk customers before they churn for retention campaigns. Fourth one is information dynamic, informing dynamic pricing and inventory decision based on the demand patterns. This is a fundamentally two machine learning problems and unsupervised clustering for segmentation and a collaborative filtering for product recommendation to the customers. And coming to the data set and data cleaning, here we can see the shape of the data set is nearly 5 lakh 41,909 and 8 columns. Here you can see the column names, invoice, stock code, description, quantity, invoice date, unit price, customer ID, co- country. These eight are the columns, and we can see top five invoice number, stock code, and description means the product description, quantity, and invoice date. And coming to the data set info, in this you can see the eight column names discussed above, and all are non-null and some are string, some are int, some are float. You can see float we have two, int we have one, string we have five columns. Coming to the missing values, here we have missing values per column. We can see the invoice number, no missing values, stock code we have no, but description we have 1454 values, missing values are there, and quantity have no, invoice data also no, null, customer ID have nearly 1,35,080. So we have removed the duplicate rows, 5,268, and unique invoice numbers. That means unique invoice numbers we have 2,59,000 and unique customer IDs. That means customer IDs we have unique is 4,372, and we have countries that are unique is 38. And coming to the data preprocessing, we have removed rows which have missing columns. That means missing values. We have customer ID nearly 1 lakh above missing values, and we have excluded cancelled invoice starting with C. That means the invoice numbers which are starting with C we have removed, and also we have removed negative or zero. That means quantity or unit price we have zero or negative values that are removed. Here we can see before cleaning the data set have nearly 5 lakh 41,909. But after cleaning, we have 3 lakh 92,692 values we have. Nearly 1.5 lakhs values are removed. And coming to VDA, It is a transaction volume by top 10 countries. That in the top one country, we have United Kingdom because the data set comes from United Kingdom. So United Kingdom stands in number one and second Germany, third France, like they're followed by the countries and top 10 best selling products. That means which products selling more. We have listed top 10. The top one is paper craft, little pride. Second one is medium creamy top storage jar, and followed by the products. And in this graph shows this monthly revenue trend. The January we have the same, and coming to February the monthly revenue trend was down and up for March, and it is increasing and decreasing, increasing. But the peak of this month trend is November. In the November we have nearly 1.1 above monthly trend. Coming to this distribution of transaction value, it is a flat line, flat, not flat, and it is a slightly decreasing line we can see is. And coming to the step 4 RMF feature engineering. R means recency. That means days since each customer last price. That means the customer when he last purchased in the e-commerce website. The frequency. That means the customer how many times he purchasing a certain product, and monetary total amount spent by customer. I computed this for every customer, giving me one row per customer, which these three numbers. The distribution conformed with what the EDA hinted at. Monetary is a particular is extremely skewed. The median customer spend about 670 euros, but the maximum was 2 lakhs 80,000 euros. A handful of customers are massive offers. We can see the shape of this data set and 4. We have added recency, frequency, monetary. And you can see RMF recency distribution and frequency distribution, monetary distribution. And coming to standardized RMF and choose number of clusters. RMF data is heavily right skewed, which makes raw standard scalar clustering collapse into one giant cluster plus tiny outlier cluster. We apply a log 1p transform first to tame that scheme, then standardize this produce much more balanced business usable insights. Then we have used elbow method and pseudo score to fix k. Here we can see elbow method and pseudo score. And coming to the label clusters, I mean clustering methodology, this queue is most important technical decision in this the whole project. If I standardize the raw RMF values and run k means directly, the few extreme spender dominates the variance and k means collapse almost all customers in one giant cluster plus a couple of tiny outlier clusters not useful for business segmentation. So you can see we have given recency rank, frequency rank, monetary rank, composite rank. Mm, yeah, we visualize it is 3D view that it is a recency, the frequency, and boundary. In the recency, we have more values, and we have saved the model to run the Streamlit app. So we have saved in the pickle file. Here we can see we have three pickle files, and we have done recommended system also in the starting of the project. We are told that for product recommendation, I have used item based collaborative filtering. I build a customer by product matrix. Each cell is how much of given product a given customer brought. That means then computed cosine similarity between products based on that matrix. Two products are similar if the same customers. 10 by 10 to buy both. For each product, I keep the top 20 most similar products given a product name. The system returns the five most similar ones. Here we can see here we are on top 20, which gives the top five. When we type one product, it gives the top five which relevant to the product name. Build a top 20 similar to look up for 3877 products. And we also saved a similarity pickle because when we type it gives the recommendation top five. So we have saved the pickle file. All the pickle files are imported in the Streamlit app, and we have run the Streamlit app. Here we can see there is a Streamlit app web application for the shopper spectrum, customer segmentation and product recommendation in e-commerce. Here we can see segment guide. The segment guide we have high value. That means recent frequency, big spenders. Your best customers. Regular, steady purchases who but fairly often but are on top spenders. Occasional, infrequent buyers who purchase now and then. At risk, haven't purchased in a long time at risk of churning. How it is work recommendations. Item-based collaborative filtering using cosine similarity on product purchase study we have discussed before and segmentation. For segmentation, we have used RMF features, essential feature, frequency and monetary. We have used a log P to transform scaling that for the k-means clustering. Then we have loaded the models 300 and 3877 products indexed, and we can here can type here similar web app. We have product one is product recommendation. Type a product. We can here we want to type a product name and it gives, and we can enter it gives top five that relevant to the product as course. Here 1 minute we can see. We go to the CSV file. Where is CSV? I got it. Copied, and I am pasting here, and I will enter get recommendations. The top one product Gin plus tonic diet metal sign, which is similar score is 0.7502, and the second one is red hanging hot tea light holder, which is similarity 0.6587, unwashed metal sign, and followed by laundry 15C metal sign. Like that. Here we can increase 8, and again we get recommendation. It gives 8 products like that. And coming to the module two, it is a customer segmentation. The customer segmentation, we have to enter the recency and we have to enter the frequency and we have to enter the monetary. Then after we want to click the predict cluster, and the app tells the segment that means high value or regular or occasional or at risk. You can see that directly we predict the customer is occasional. That means he buys occasionally, not regular. So we can increase the frequency like see, and we can predict the customer buys regularly in the e-commerce website like that. We can increase the monetary we can so regular again we increase on theory regular, but we increase this recency again regular. We can yeah, this customer buys high value. That means he buys very frequency in the e-commerce. And finally, I conclude that I took 5,42,000 raw transactional records and cleaned wait, and cleaned them to down a reliable 3,93,000 values, engineered RMF features, built a long log transformed k-means clustering model that produces business meaningful clusters segmentation, built an item based collaborative filtering recommendation engine and shipped both as an interactive Streamlit app. That is the conclusion of this project, the project of the Shopper Spectrum